This question is asking how much heat would 180 grams of water release when they change from water at 0 degrees to ice? So this means, are you going to choose the molar heat of vaporization or molar heat of fusion? Of course, you will use molar heat of fusion. But mister, this is changing water to ice while this is fusion, so ice to water melting. Yeah, it is the same, but only the opposite direction. But you cannot use this one because this is from gas to liquid. For every 1 mole of the substance, you are changing from liquid to solid or solid to liquid. There is 6.02 kilojoules absorbed or released. What if you have 180 grams? Again, I will change from the mass into the number of moles. The number of moles is equal to mass over molar mass. That's 180 over 18, so equal to 10 moles. If 1 mole gives 6.02, so 10 moles, what is the amount of heat? Will 60.2 by cross multiplication kilojoules. Because of its excellent heat conductivity, liquid sodium has been proposed as a cooling liquid for use in the nuclear power plants. How much heat would be absorbed per kilogram of sodium to melt the solid when the cooling system is put in operation? Now I'm changing from the sodium solid into liquid melting. So I will choose the second one, solid into liquid again. I will not choose that of vaporization. 2.63 is per mole. What if it is 1 kilogram of sodium? Number of moles is equal to mass over molar mass, which is 1 kilogram over 23, 1000 gram over 23. That's 44.5 moles. If 2.63 was produced from 1 mole, so how much heat will be produced from 44.5? So that's equal to 117 kilojoules by the cross multiplication. Part B is saying how much heat would be absorbed per kilogram of sodium if the temperature rose too high and the sodium vaporized. Now, if it is 1 mole, it will be vaporized for 101 kilojoules. So 44.5 moles, how much kilojoules? Again, the cross multiplication, so 44.5 multiplied 101. You'll need that amount of heat, which is 4494.5 kilojoules to vaporize it. Now let's compare the energy of the molecules in the 3 states of matter. The highest potential energy is in the gases, while the lowest is in solids. And liquids is in between. It's less than that in gases and more than that in solids. What about the average kinetic energy? The average kinetic energy for the particles is the same in all states of matter. So what are the factors that affect the average kinetic energy? During the melting, the energy absorbed is stored as potential energy. The energy which is stored is used to change the state from solid to liquid and not to raise the temperature. Therefore, the temperature stays constant. So this is our heating curve. As the temperature increases, what happens? The kinetic energy increases, but the potential energy stays the same. So in this part from A to B, the temperature increases. So the kinetic energy of the particle increases while the potential energy stays the same. It's still in the same phase. Like if it is solid, it's still in the solid phase. If it is still in solid, the potential energy is the same, only the kinetic energy is increasing by increasing the temperature. Now at a constant temperature, the PE increases because you are changing from solid into liquid. So you have two phases here. So you have two different potential energies while the kinetic energy stays the same. This is because of the energy that was stored from the kinetic energy now is helping to break the bonds from the solid into liquid and change the state. So again, say what happens from A to B. You are in the same phase. You are still solid. So the potential energy is the same, but the kinetic energy is increasing. From B to C, what happens? You are in different phases, in solid and liquid together. So your potential energy is going to change. Why? Because you are changing the phase while the kinetic energy remains the same. Again, from C to D, you are No, you are still in liquid, so your potential energy is the same and the kinetic energy increases. The average kinetic energy is directly proportional to the absolute temperature. At constant temperature, average kinetic energy remains the same. If a molecule on the surface of the liquid is given to sufficient push, so it's given a sufficient push from below, it may be able to escape and join the gaseous state. It jumps out with a lot of kinetic energy that's stored as potential energy. So again, I have a particle that was able to jump. This particle was able to jump from the middle of the liquid. It was given sufficient push from the below, so it's able to escape and join the gaseous state from the liquid into gas. It jumps out with a lot of kinetic energy that's stored as potential energy. And the average kinetic energy of the remaining molecules decreases, the liquid cools down. When liquid evaporates, its vapor pressure starts to rise. Why? Because most of the liquid is changing into vapor now with collisions causing the vapor pressure to increase. The molecules coming back and join the liquid at the same rate they are escaping. So there is evaporation and condensation. The net amount of liquid molecules and gas molecules become constant. No more cooling takes place because the rate at which molecules leave and the liquid is equal to the rate at which the molecule come back and heats the liquid. This is equilibrium. This is the maximum or equilibrium pressure that's called the vapor pressure of the liquid at a given temperature. When we sweat on very humid days, our bodies don't cool down because here you are trying to sweat while the particles are not able to come up. Because if they are trying to come up, they will find that already it's too humid. There is too many vapor in the air around us. You cannot cool down. So we cannot remove the particles of liquid of the sweat from your skin because they cannot be changed into gas, so we cannot cool down. We also know that the vapor pressure increases with increasing temperature. When the vapor pressure equal to the atmospheric pressure, the liquid boils. Sometimes liquid is heated to a temperature above its boiling point and does not boil. This liquid is said to be superheated. You're trying to increase the temperature boiling, but it's not boiled, so it's called superheated. Why this is very dangerous? It's dangerous because cause some agitation, which will cause the liquid to evaporate, explosively spraying all with very hot liquid outside. To prevent the superheating, we have to add a few pieces of boiling chips in the liquid before boiling it so that it does not cause the superheating.